purpose of this quick video is to just remind you a little bit about what the normal distribution is. The normal distribution is used to describe the variation of a given distribution. So one of the things that makes the normal distribution so important is that many processes in real life behave just as the normal distribution does. So the way that we look at this is that we can see the area under the curve to be the proportion of the data that falls within certain ranges of the normal distribution. So, for instance, there are two parameters that actually describe the normal distribution, and one of them is the mean. And we are talking about parameters here. So this is the mean of the distribution, and the second parameter that describes the normal distribution is the standard deviation. So if we know both of those parameters, then we are able to kind of get a feel of what the distribution looks like. You've probably heard a lot about these rules of how what percentage of the data falls within certain standard deviations of the mean, and for instance, within one standard deviation of the mean, we can find, or we can, if the process behaves as a normal distribution, then we have about 68% of the data, and about 95% of the data within two standard deviations, and about 99.7% of the data within three standard deviations. So basically, if we know these two parameters of the normal distribution, we are able to describe pretty much most of where the data falls. Now, there are a few things that are important for normal distribution, and it is centered about the mean, so that would be one of them, centered around mu. And the second characteristic is that most of the data is within three standard deviations. We can see that the probability that a data point or some observations are below three standard deviations away from the mean to the left side is very remote. Same thing here. The probability that we have points above that is actually very small. But having said that, it doesn't mean that the probability is zero. There is a distinct probability that there are points beyond here. In fact, there is some probability, even if infinitesimal, that there is there's some probability anywhere in the number line. But most of the points fall, so most of the data falls within three standard deviations. Okay, so that's another characteristic that is important to mention for a normal distribution. And third characteristic is that it's symmetric, which is the fact that if we part this distribution and break it in two, one side is the mirror image of the other. So we have 50% probability in one side and 50% on the other side. So if we are able to understand that and how it behaves, then we kind of have an idea of where the probability falls, and it is easier for us to understand. So for instance, in your notes, we have a couple of examples that are important to note. So let me just point out to one of them. And one of them is, if suppose that the heights of students are normally distributed with a mean of 66 inches and a standard deviation of 3 inches, then find the proportion of students taller than 70 inches. Okay, so let's go here and talk about this. Well, first of all, we are going to describe the problem here. So this is the example, and we are going to set let x be number of inches tall of students, and we know for some reason, I mean magically, we know that this mean is 66 inches. Again, I say magically just because it's very unlikely that we're going to know for sure what that population mean is. But for now, let's assume that we know it. And we know that the standard deviation is 3 inches. Well, the question is, what's the probability that a given student, or the proportion of students that are greater than 70 inches? So this probability right here can be expressed many ways. We can say this is the proportion of students greater than 70 inches. We can also say this is the probability that a given student is more than 70 inches tall. So there are many ways that we can phrase this particular mathematical notation here, but we are just gonna change them. We're gonna use them interchangeably. So the proportion of students greater than 70 inches, or the probability that a given student is more than 70 inches tall, for our purposes is the same thing. So in this case, we know that we are centered around 66. So if we go here to this particular graph, we know that this is 66 inches, and we know that we want to have the probability that a given student is more than 70 inches, which is right around maybe so right around here, a little more than 1 standard deviation away in the upper quadrant here. So it's 6. So we can see that 1 standard deviation away would be 66 plus 3, so that would be 69. So it would be like right here. What is the probability that a given student is that or more? So we're saying at least that. So we want to get, in this particular graph, we are wanting to get anything above 70. Okay? By visual inspection, we know that this probability has to be less than 50%, because we have 50% from 66 above and from 66 below. So 69 would be something below around so it would be anywhere between 0 and 50%, but it has to be less than that. Okay. So having said that, we're gonna go ahead and try to get what that estimate is, and we are going to rely on tables. We are going to rely on computers. In this class, I want you to just go ahead and get that probability from anywhere you feel comfortable getting it from. I'm gonna show you how to do that in R, but it is important that you understand, visualize every problem by just taking a look and having a guess of what that probability should be, because that's gonna help you get the code correct. In R, this is going to be obtained using the pnorm function. The pnorm function basically gets a cumulative distribution, cumulative probability, but the pnorm function actually by default obtains the probability of a given point and below. So you gotta understand, so what you have to understand is what the function is giving you. By default, the pnorm function, if we were to plot a normal distribution and we have the value of 70 here, the mean of 66, by default is just gonna get the value of that point and below. So it is important that you understand that of the function p-norm. You can actually get this probability by doing 1 minus p-norm, or the p-norm value that you're going to get of 70 and a mean of 66 and a standard deviation of 3. Or you can also do something within the p-norm function to just give you that upper tail. And we're going to go ahead and do that in R in just a couple of minutes. But this is an important example to understand the cumulative distribution function of the normal distribution.